In this video, we are going to be focusing on solving story problems that deal with quadratic equations, specifically in standard form. At this point, you should have already spent some time going over numbers 1, 2, and 3, kind of looking at them, attempting them on your own. I really don't expect you to have solved these problems yet, but I wanted you guys to kind of take a look at it to process what's going on before we dive right in. So if you haven't done that yet, please pause the video, take some time just to look through these problems, highlight or underline the key information, maybe draw a sketch if that's helpful, and then we will, and then continue the video when you've already done that. All right, so for number 1, it says Amir stands on a balcony and throws a ball to his dog who is at ground level. The ball's height in meters, t seconds after Amir threw it, is modeled by this function. I look at this, I see it's quadratic because I see a t squared. Specifically, it's in standard form because I see a t squared and a t. I see that the leading coefficient is negative, so it's going to be a parabola that's opening down. So if I wanted to draw a sketch just to kind of visualize what's going on, it makes sense that here, if Amir's on the balcony, he starts here, he throws the ball, his dog's down here. This is a parabola opening down, so it would continue on forever. But we're probably only looking at this portion from where he threw it to where the dog is. So it says, after how many seconds did the ball hit the ground? So this is the equation I'm dealing with. I want to know when it hits the ground. So if I look at the graph, this is really where I'm looking at right here, is where it hits the ground. That is the x-intercept, or in this case, because we're using t instead of x, the t-intercept. So I can think of that two ways. One, I need to find the x-intercept. That means that's when y is 0. In this case, h of t equals 0. Or just think about when you hit the ground, what's your height from the ground? Because it tells you that the ball's height is given as h of t, which means that when you're on the ground, your height is 0. So either way, you can think of it as 0. So now I can substitute in 0 equals negative t squared plus 6t plus 7. I know it's quadratic because I see a t squared. We said again it's standard form, so it's t squared and a t, which means if we do what we did yesterday, we had to solve this using the quadratic, or solve it by factoring, and then using zero product property. So my first step in factoring is to factor out the greatest common factor. And we said whenever the leading coefficient is negative, we like to factor out a -1. So I'm going to say that the GCF is -1 and factor that out. That's -1 times, and it essentially changes the sign of all of these terms, because if I were to distribute that -1, that's what I would get back. And then I continue factoring inside the parentheses because I have, it's still quadratic, so I identify my A, B, and C. A is 1, B is -6, and C is -7. And so I need two things that multiply to be A times C and add to be B. That would be a +7 and a -1. Oh, nope, that's wrong. That adds to be +6, a -7, and a +1. Now, I could go ahead and do the box after this, or factor by grouping, but I'm not going to, because we talked about yesterday how if A is 1, I can actually use these two and jump right to my factors. I can instead say 0 equals, I still have my GCF of -1, but now this is going to be a t minus 7 and a t plus 1. Now it's in factored form, and we talked about last week how if it's in factored form, I can use the zero product property because I have the product of 3 different factors equals 0. So either -1 is equal to 0, which it never will be because there's no t to even solve for, or t minus 7 is equal to 0, or t plus 1 is equal to 0. And if I solve this equation, I get t is equal to 7. If I solve this equation, I get t is equal to -1. So let's think about what that means graphically. Go back up here. This would be my x-intercept of 7, 0. This over here is my x-intercept of -1, 0. The -1 is not actually going to be one of our solutions because it's not really within the domain for our story problem, right? It doesn't make sense to have a time at -seconds. So before he even threw it, it's at the ground. That doesn't really make sense using this function. So I'm going to cross that out because it does not make sense in the context of the problem, and instead say that my solution, or my answer, is 7 seconds. Or if I wanted to write this as a sentence, the ball hit the ground after 7 seconds. Now, we've already done some of these problems using graphing calculators, so you could use your graphing calculator to verify as well. Jumping to the next one, it says, if Amir's dog is able to jump 12 feet into the air, when could he catch the ball? So he doesn't need to wait for it to hit the ground. If he can jump 12 feet in the air, that means his height, h of t, is 12. So we could say 12 is equal to negative t squared plus 6t plus 7. And now I have a quadratic equation that's almost in standard form. I still see a t squared and a t, but it's not equal to 0 yet. So let's subtract 12 from both sides. When I do that, I'm going to subtract it from the 7 because those are like terms. Neither one of them have a variable. So we have 0 equals negative t squared plus 6t minus 5. And now I can solve by factoring as well because we have a t squared and a t and it's equal to 0 now. The GCF is still 1. Or sorry, negative 1. So I have negative 1. Negative 1 times t squared gives me the negative t squared. Negative 1 times a negative 6t gives me the negative, or positive 6t. And negative 1 times a positive 5 gives me that negative 5. So now I have a is 1, b is negative 6, and c is 5. So when I do my product sum, or my x, I need two things that multiply to be 5 and add to be negative 6. Those numbers would be a negative 5 and a negative 1. And again, because a is 1, I can skip doing the box and I can just say 0 equals negative 1 times t minus 5 times t minus 1. Because I have this in factored form, 3 factors multiplied together equals 0. One of them has to be 0. Well, negative 1's never going to be equal to 0, so that's not going to help us. But if I set these other 2 factors equal to 0, I can solve for t, and I get t equals 5 or t equals 1. So let's think about what this means. If I go back up to my little sketch here, I go back to here, if I go where the height is 12, so 12 would be up here. Oh, actually probably even higher, that's bad. You have 2 different spots where it intersects at 12, which is the 2 solutions. So after 1 second and after 5 seconds, the dog would catch the ball. Which really that means the dog could jump up and grab it before it's even reached its peak, its maximum, or it could grab it on the way down. So the dog could jump up and grab it before on the way up, or on the way down. So both of these are possibilities. So if I was answering this as a question, I would either say 1 second or 5 seconds, or as a sentence would be he could catch the ball after 1 second, meaning on the way up, or 5 seconds, meaning when the ball is on the way down. And there you go. There's our answers here. For the next one, it says a toy submarine follows a parabolic path. Parabolic just means is the adjective for parabola. So meaning the path is a parabola as it descends and ascends in a pool. Descends meaning going down, ascends meaning going up. The function y equals 5x squared minus 5x models its path where y represents the location of the submarine that many inches from the surface, and x is the number of seconds since it left the submarine. How long is the submarine underwater? I think it's always easier to look at a graph for this, so let's just type this in. 5x squared minus 75x. If I look at a graph, this is what's happening. It's hard for me to see this, so maybe I need to zoom out. So let's change that window. Let's just say -1. Let's increase this to, I don't know, 30? So now let's create a graph. Goes further to the right. So we're still looking like it's not super helpful. Okay, so let's change that window again. Let's change our y minimum. Looks like it's going down further. Negative, let's say 100. What does that graph look like? So we're starting to see more now. Let's continue to change that. I don't need to go out that far. Let's make that 20 and instead make this -200. What does this graph look like? All right, we're able to see it a little bit better. I just need to go down a little further, so let's make it -300. Okay, now I can start to see the graph. So the submarine goes down, it hits its lowest point, and then it goes up. So it descends and then ascends. And we want to know how long is it underwater is what it's asking. So it starts underwater here, and then it goes down, it comes back up underwater here. So we really need to find this point. We need to find that x-intercept. So again, think through like the first one. If you're finding the x-intercept, that means y is 0. Or it's underwater, or when it's at the water, the height is 0, y equals 0. So y represents the location of the submarine inches from the surface. Well, if it's at the surface, that means y equals 0. So I can go to 0 equals 5x squared minus 75x. and now I need to solve this equation. All right, there's a couple different ways you could go about solving it. One way is to think through what is the GCF. And if you recognize that both terms not only are divisible by 5, but also divisible by x, meaning they each have an x you could factor out, you could say 0 equals 5x, and then it would be x minus, and 75 divided by 5 is 15, so x minus 15. So now when I look in the parentheses, this is linear. I don't see an x squared, so I'm done factoring, and it's in factored form, so I could set 5x equal to 0, use the zero product property, and I get either x equals 0 or x equals 15, which if we think through this means that graph, one x-intercept is 0, one is 15. So you start here, you go down, come up. At 15, what are the units on this? Seconds. So at 15 seconds, it's back at the water. So it's under for 15 seconds. I can get these same solutions by doing this a little differently. You could say, if you didn't recognize that they both have an x you could factor out, you could say you're factoring out a 5 and just say x squared minus 15x, in which case you would need to recognize that a is 1, b is your coefficient of x, so that would be negative 15, and because I don't see a number without x, c is 0. So now if I'm factoring using my x, 1 times 0 is 0, negative 15, I need to multiply to be 0 and add to be negative 15. The only numbers that do that are 0 and negative 15. Again, because a is 1, I don't have to do the box. I could say 0 equals 5, and then I could say x plus 0 and x minus 15. And you could break it apart to say, okay, is 5 equal to 0? No, it's never equal to 0. X plus 0 equals 0. X minus 15 equals 0. Well, this is just x equals 0, and if I add 15, I get x equals 15. So you see it's the same solution. It's really whatever method you prefer. You'll see me doing it like this because I believe that's more efficient, but this isn't that much more work, so you could do it that way as well. Either way, what we find is that the submarine is underwater for 15 seconds. All right, and then the last one I want to go over in the video is this bottom one. It is kind of a challenge problem, so bear with me. It says a town has a nature preserve with a rectangular field that measures 600 by 400 meters. So here's the original field. They're going to add on to it, and they want to double the area. So we want to double the area. We need to find the new dimensions of the field. And when we say dimensions, it means its length and width. So if I want to double the area, I'm thinking through this. I'm thinking, well, I need to first figure out what is the original area, and then what would that be doubled. So the original area, the area of a rectangle is base times height. So the area would be 400 times 600. So the original area, if I do 400 times 600, is 2, 4, and then there's 4 zeros. So what is that? 240,000 square meters. If I want 2 times that original area, that would be 480,000. Because these dimensions are in hundreds, to make this easier, I want to write our equation in hundreds of meters. So make a note. We're going to let x equal 100 meters. Okay, so x is going to represent whatever addition we have, but in hundreds. So if I say x is 2, that means that's really 200. If I say x is 3, that's really 300. If x is 4.5, that's 450 meters. Okay? So if we look at this, the new area is still a rectangle, so it's base times height. The new area is going to be 480,000, but if we're going to do it in hundreds, that would just be 4800 equals, the new base would be this length right here. It would be x plus 400. But if we're doing it in hundreds, it would just be x plus 4. And then this next one would be x plus 6. Actually, you know what? Sorry, this would not be 4,800. This is x equals 100 meters. So if we're in square meters, 100 times 100 would be 10,000. So sorry, this would actually be 48. My apologies. 48 equals that. Okay? So now we have to figure out, well, how do you solve this equation? Well, it looks like factored form because we have two factors multiplied together to equal a number, but it's not 0. And you can only solve factored form equations if it's equal to 0. So right now it's not. So this is the challenge. We need to get this into standard form first. So I can multiply this out using the double distributive property or the box, whichever method you want. So that's x times x plus 6 plus 4 times x plus 6. So that's 48 equals x squared plus 6x, and then 4x plus 24. So now if I combine those like terms, I get x squared plus 10x plus 24. It's not equal to 0 yet, but I can subtract 48 from both sides, and I get 0 equals x squared plus 10x minus 24. Now I can solve this using the using factoring. So I need two things that multiply to be negative 24 and add to be 10. And those two numbers, what would that be? 12 and negative 2. So when I solve this, I get 0 equals, I'll get x plus 12 and x minus 2. And if I now solve using zero product property because I have the product equals 0, I get x equals negative 12 and x equals a positive 2. Well, a length of negative 12 doesn't really make sense. So this is really our only options. But remember we said x is really x is 100 meters. So, or it's in hundreds of meters. So if x is 2, that would really be 200 meters. So this should be 200 meters, and this should be 200 meters. And let's just verify that this is correct. That would make this total of 600, and that would make this times 800. 600 times 800 gives us that area we wanted, so we're good to go. So the dimensions now are going to be 600 meters by 800 meters. These are the new dimensions. So that's my final answer. Now this is definitely a more challenging problem. I want to show you this video. Use this in order to help you with this challenge problem down here, but if you don't get to that challenge problem, that's okay. I do want to make sure that you find a partner and you work through these two problems here. These are the ones that I want you to leave class having done. You should get an answer key to check your answers, but there will not be any more video to watch. So use what we did in the video for these problems on the front in order to complete with a partner the problems on the back, and then you can use my answer key to make sure that you are doing them correctly. Good luck!